Everyone, this is Hossein Mokhtarzadeh, and today I'm going to talk about self-paced treadmill with Motek Devices. This is our disclaimer. As the name self-paced treadmill would suggest, it actually tries to help maintain the same speed that the subject has. So the subject will stand on a treadmill, just walks. If he or she walks behind, for instance, like close to the end of any edge, and then there would be a correction from the controller so that the belt speed will change or accelerate or decelerate, so that the subject will be around middle of the treadmill. So there's lots of different algorithm, but we have a specific algorithm that we're going to share eventually. So I'm going to tell you a little bit about what other people have done. I've used quite lots of people actually, maybe more than 10 different studies have been using Motek self-paced algorithm. This is one of the recent one. And then you can see that the calculation is here with different sensitivity that we define within the system. So you see that the belt speed changes based on the center of mass, speed, and velocity. The algorithm actually uses these two, and that's coming from the pelvic like markers. You can actually define center of mass as you wish, but this is coming from that. And then, it sort of goes to a steady state as the subject to start from zero speed, and then there would be some sort of like a comfortable speed. So I would like to show you how we can do it in DFlow. This is the DFlow environment, which connects all the hardware and software, as you know. And yeah, please join us while I'm sharing with you how to do it. So this is one way to do it. So we have someone walking, so there's a mocap and the file, just I prepare something from before, and these are the markers basically. So if you start it, you can see that this person starts walking, and we use all these 4 markers around the pelvis, and then we use them and get the average of them. So we can have expression as well. So the average of all these channels, as you can see here, all these position, Z is the direction of anterior posterior. So you see all these 4 markers. So this one and that one, they're the same concept. So I just wanted to compare them, that's fine. And this then statistic, the output of that, which is average, will be given to the treadmill. The treadmill here, the self-paced position of the Z. And then basically you run this and activate the self-paced mode, and you'll see how the subject will move to that steady state of speed. So then basically I show you the graph here. So that brings one of the belts. If you have to like a 12 instrumented basically treadmill, I've got left and right speed, and then there's no difference in this algorithm. We show one of them here, the speed of 1. So let's just start over, and then when I run this one and start the treadmill and then activate the self-paced mode, you can see basically using these markers, we are going all the way that this is the belt speed calculation, as I showed you in the description or presentation. So this goes all the way to sort of a steady state. Hope this will be useful, and let us know if you have any questions.